All right, this is problem number 9 from homework 2.3 in web design. It is actually the number 38 from the book's exercise in the section 2.3. So here we have 6 natives, U, V, W, X, Y, Z, and then we need to identify whether each one is a knight or knave. Knight tells the truth and a knave tells a lie. Okay, so just a quick comment. For problems like that, there are always more than one way to solve it. You can do it in many ways. However, a rule of thumb, you do not want to assume all of them are knights or all of them are knaves to begin with. You're going to just pick some of those, just pick one to begin your assumption. Assume it is a knight or a knave and then see if you can derive to a contradiction. Once you can derive to a contradiction, then what you assume is incorrect and you can lead to a conclusion. So now let's begin. Okay. So there were 6 people. The U says none of us is the knight. This is a pretty strong statement. Everyone is not a knight, basically. None of us is the knight, okay? So therefore, I'm going to begin with what U says, okay? So let's begin with what U says. So now, to begin your problem, you assume, just pick one. If assume U is a knight, say suppose, assume U is a knight, that means U is telling the truth, right? So which means U says truth. Okay, allow me to skip writing, not making the whole complete sentences because I don't want to make the video super long. So in other words, tells truth. That means no knight at all. None of them is the knight. No knight at all, right? So no knight at all. Well, do you feel like this is already a contradiction? Because if we assume U is a knight and what he says is no knights, this is already a contradiction. No knights, but there is a knight. So this is already a contradiction. Contradiction. That means what you assume is not right. So in other words, therefore, you can conclude U is a knave. So that's not too bad. So knave, let's document that down. So in other words, what U says is a lie. So in other words, this is a lie, right? This is not true. Its negation should be true. Well, this none of us is a knight. That means all are not knight. Well, usually writing this into universal statement is easier to find a negation. That's why I kind of rewrite that. So its negation is some are knight, right? Some are knight. Okay, at least one is a knight. So therefore, let me actually copy this down. Copy this down. Oops. Actually, let me move this. Okay, let me just write this down. So therefore, some are knight. At least one, okay? At least one. At least one is knight. Okay, now you can skim through and see which statement is easier for you to continue the problem. And you can certainly, I encourage you to pause the video and then think about it before you resume the video. So here, I'm going to take a look at what Z says, okay? Because exactly one of us is a knight. So now let's take a look at what Z says, okay? So that's my step 1. Step 2, I'm going to take a look at what Z says. So we will have to assume, just like what we did here, begin with the assumption. If Z is a knight, that means again that means what Z says is truth. So in other words, exactly one of us is the knight. Only one knight, right? And because we assume Z is knight, then Z is the only knight. Then Z says truth, and Z is the only knight. Okay. Now, Z is the only knight. Okay. Then seems like that's it. We cannot really go anywhere at this point. And let's continue to read. W says, at most 3 of us are knights. So you have to somehow get familiar with each statement. So W says, at most 3 of us are knights. Do you feel like at most, when there's only one knight, this is also a true statement, right? At most 3, that means 3, 2, or 1, or 0. So one knight certainly is, when there's a one knight, certainly at most 3 of us are knights. This is a true statement. So in other words, then what W says is true. So when someone says the truth, then W is a knight, right? W is a knight. Do you feel that there's a contradiction now? Because Z is the only knight, now you derive that W is another different knight, right? It's a knight. So therefore, a contradiction. A contradiction, okay? So that means what you assume is false. Z cannot be a knight. Therefore, Z is a knave. Okay, so therefore, Z is a knave. Okay. Well, okay. Okay, now, again, sometimes I have to think about it. So, let's look at what X says. So now, take a look at what X says, okay? So, now, so far, 2 knaves. Okay, keep in mind, out of 6 people, right? 6 natives. 6 natives. So 2 already are knaves. That's a fact. So take a look at what X says, okay? Now, X says there are exactly 5 knights. I hope that you can feel like exactly 5 knights and 2 knaves. This certainly will make more than 6 natives already, right? So therefore, this is not going to happen. Exactly 5 knights. Exactly 5 of us are knights. This cannot happen. This can happen because there are already 2 knaves out of 6 natives. And the most you can have is just 4 knights, right? Exactly 5 knights, this just can't happen. That means what X says is that, i.e. X lies, right? X lies, and you can conclude that X is a knave. So we've got another one. So X is also a knave. Okay. Now, how many knaves do we have now? So we have, so far 3 knaves. 3 knaves. At least 3 knaves. We know at least 3 knaves, right? So therefore, take a look at when we have at least 3 knaves, 3 or more knaves. That means we cannot have more than 3 knights. So therefore, at most 3 of us are knights have to be true, right? So therefore, so this is the step 4 now. Therefore, what W says has to be true. In other words, W is a knight, right? Okay, so we do know that this is the first knight that we see. Okay, now and let's continue to read. V says at least three of us are knights. At least three of us are knights. And so we pick V. Let's just pick V. Assume V is the knight, okay? So suppose, and you just pick one and assume. Okay, I'm gonna call this as my 5 step. If V is a knight, that means at least 3 are knights, right? That means at least, because telling the truth, knight tells the truth. At least 3 knights. Okay. Well, again, what W is a knight. That therefore, at most 3 knights. That would be also true, right? And together with and plus what W says, at most 3 knights. Okay, at least 3 knights, at most 3 knights. That I hope that you can conclude that exactly 3 knights, right? Exactly 3 knights. That's what it says. Well, because we already know U, X, Z are knaves, and then if exactly 3 knights, then V, W, Y, they are the only 3 knights, right? So therefore, we can conclude that Y has to be a knight, so that there are 3 knights. Okay. Take a look at what Y says. But Y says exactly 2 are knights. Therefore, Y cannot be knight, because if Y is a knight, then what he says is true, and which will contradict to exactly 3 knights, right? But what Y said, so what Y said is a contradiction. Is a contradiction. So when you have a contradiction, what you assume is not true. So therefore, V is a knave. Then you can know that V is a knave. So therefore, V has to be a knave. Now, so far, how many knaves that we have? We know 1, 2, 3, 4. U, V, X, Z. They're all knaves, right? 4 knaves now. So far, 4 knaves. Okay. Now let's take a look at. I think at one point we derived that there's at least 1 knight. Okay. Why we say that? Why we say that? Actually, I don't think that I said it earlier. So earlier I forgot to mention one thing. Z is a knave. Z is a knave. Therefore, what Z says is gonna be a lie. Okay. So therefore, not exactly one of us is a knight. We also know that U is a knight. So U is a. U is a knave. What U says is wrong. Therefore, its negation will be true. Some are knights. That means at least 1 is a knight. At least 1 is a knight. And plus, what Z says is wrong. That means it's not true. Exactly 1 is a knight, right? It's not true. And plus, this fact, at least 1 is a knight. Do you feel like there has to be more than at least 2 knights? So now this i.e. the negation is true, right? And plus, there are some knights, right? Therefore, combine these two. Therefore, at least 2 nights. I should have said that sooner. Now let's take a look at because at least 2 nights we have a night W. So let's see. We have to have another night. So let's see. Therefore, Y has to be night, right? Okay. So last step, because there must be at least 2 nights, and W is 1, then Y has to be the other one, the second one. Sorry, my writing is not nice. And then let's take a look at what Y says. Exactly 2 of us are knights. So what he says is true. It's consistent, right? So therefore, Y has to be knight. So we solved this problem. By the way, not the best organization. The purpose is to walk you through how logic can be used to solve a problem that's almost impossible to solve if we do not know the logic.